Today's assignment, page 17, which is 53 to 73 odd. You're welcome. Yes. And then 75, is this, let me look. 75 through 78 all. Oh, sorry, 57. You're right. 57 to 73 odd. Because 53 is not even on page 6. It's on page 16, not 17. Okay. So if you turn to page 17, we have more story problems to do. Aren't you so excited? So I'll set some of these up for you. A patient requires an IV of 0.9% saline solution, also known as normal saline solution. How much distilled water to the nearest milliliter must be added to 100 milliliters of a 3% saline solution to produce normal saline solution? So we want it to end up being 0.9%, which is just less than 1%, right? So how much distilled water to the nearest milliliter must be added to 100 milliliters of 3% saline to produce normal saline? So we have 100 milliliters that has a concentration of 3%, and we're going to add pure water to the point that the saline drops to 0.9%. How would you set that up? So Riley said something. If you add another 100 milliliters, you'll be where? So Riley said if we add 100 milliliters of water, it will drop down to 1.5%, which is not enough. So it's got to be more than 100 milliliters. What if I added 200 milliliters? Well, it wouldn't be 0.75. So if I added another 100, I would have 200 milliliters, but it would be 1.5%. If I added another 100, it would be 300 milliliters. Nope. 0.75 would be if I doubled this. I think I'm confusing you. Let's try a different method. Okay? So, I want my total value to be 0.9%. But I don't know how much total there will be. I know I'm starting with 100 milliliters that has a concentration of 0.3. What am I going to add to that? Plus X amount of water. Okay? And what does adding X do to this ratio? We're going to keep adding X until we reach 0.9. So how much water will there be total? X plus 100. Does that make sense?
We'll now go back to code green. All squares.
So is that going to work? Oh, that's not 0.3%. It's 0.03. And this would be 0.009. What's the concentration on this? 0%. So can I times that by 0%? You could, but it's going to wipe it out, right? Times 0. Do we see a solution method? Let's try this and see if it works. So let me rewrite it. 100 times 0.03 plus an unknown amount of 0% solution needs to equal the original 100 plus x times 0.009. Well, this is nice. That goes away. So 100 times 0.03 is equal to, if I distribute that, what is 0.009 times 100? 0.9 plus 0.009x. We expect the answer to be a couple hundred milliliters from what we tried to begin with. And it's okay if you try something and it doesn't work. That's how math is. Give it a try. If it doesn't work, try something different. So 3 equals 0.9 plus 0.009. Subtract 0.9. So 2.1 equals 0.009x. 2.1 divided by 0.009. So 2.1 divided by 0.009. Oh, I'm totally in the wrong place. Does that seem reasonable? 233 milliliters? Yeah, that seems pretty reasonable. Let's give it a try and see if it works. So if I go back to the original problem, 100 at 0.03, and we're going to add 233 milliliters. That gives a total of 333 milliliters. But we have the same amount of salt that we had before. We didn't add any new salt. So the amount of salt in here is 3%, 3 milliliters essentially, right? So what is 3 divided by 333? Is that what we wanted? Now why isn't it perfect? I have 0.009, 009, 009. I rounded my 233 off. Okay, here's another way to do it. We could start with the idea of how much salt is there to begin with. So we take that 100 and we times it by 0.03. So of that 100 milliliters, 3 milliliters would be pure salt. Okay? So my original amount is still going to have 3 milliliters of salt. Right? So I'm going to take that 3 milliliters of salt and I want it to have a concentration of 0.9%. So how much do I have to divide that by to get 0.09%? So if I take 3 milliliters of salt, divide it by an unknown amount of water, I want that to equal 0.009. How do you solve a fraction with a variable in the denominator? You just switch them. So 3 divided by 0.0... Oh, Jake's laughing at me. That's okay, right back at you. 3 divided by 0.009. 3 divided by 0.009. What do you expect when I do this? I should get 3333333, but we have to think about something. That's how much water is needed for the entire solution. But I already have 100 milliliters sitting in solution. So I subtract off that 100 and you get 233. So there are a couple different ways to do the same problem. Okay? Right. 59. A motorboat can maintain a constant speed of 16 miles per hour relative to the water. The boat makes a trip upstream to a marina in 20 minutes. The return trip takes 15 minutes. What is the speed of the current? How would you do this? So there is a unit problem here. Miles per hour, and the trip is in minutes. So you have to change one or the other. You have to change either the minutes to hours or the miles per hour to miles per minute. It doesn't matter which one you do. So you want to switch minutes to hours. So what would this be in hours? So 20 divided by 60 is 1/3. So in a third of an hour, the return trip takes 15 minutes, which is a fourth of an hour. Okay. Now everything's in hours. What should we do? And this might help you. Why are the times different? So when you're going upstream, what's happening? The water's pushing against the boat, so you're fighting the current. And when you turn around and go downstream, then the boat and the current are working together. So does the speed of the river change? No. Does the speed of the boat relative to the water change? Relative to how fast the water's going? No. But the overall speed changes because sometimes they're working together and sometimes they're working against each other. So what is the one thing we don't know about this story? The speed of the water. The thing you don't know makes a really good variable. So let's say that x is the water rate. Does that help? Okay. We have two trips to talk about. Let's talk about the two trips separately. Going downriver, what's happening? So how fast is the boat traveling? 16. How fast is the water traveling? So going downriver, we have 16. And what did you say, Daryl? 16x plus x. That is the speed of the boat traveling downriver. What would the speed of the boat be traveling upriver? 16 minus x. Okay. Now what? So we have the formula, rate times time equals distance. So if I take the rate, this is the downriver speed, and this is the upriver speed. Downriver we travel for how long? 15 minutes, also known as 1/4 of an hour. And that equals distance. And down here, we have 16 minus x times 1/3. And that equals the distance. Anybody see what we should do now? We have too many variables. I have a t and I have a d. Say that again. Why are they equal to each other? They have the same distance. So we could just use substitution here. D is equal to this equation and D is equal to that equation, which makes sense because it's the same trip. You go up the river and you turn around and you come back down the river. So those two formulas covered the same distance. So essentially, 16 plus x times 1/4 is equal to 16 minus x times 1/3. I'll let you solve that. But that's what's happening. Another way you could have set it up is you could have added them together, which is probably what they wanted you to do. You could say the trip up the river was 16 plus x times 1/4 plus 16 minus x times 1/3 equals 2d. But then you have to figure out, anyway, I wouldn't do it that way. I would do it the way we did it. Okay, take a look at 61. A Cessna 175 can average 130 miles an hour. If a trip takes 2 hours one way and the return trip takes 1 hour and 15 minutes, find the wind speed. Oh, sorry. We wanted... it wants to know the speed of the current. Probably, we're working in miles per hour, so I would stay with miles per hour. Okay, sorry, 61. A jogger and a walker cover the same distance. The jogger finishes in 40 minutes. The walker takes an hour. How fast is each exerciser moving if the jogger runs 2 miles per hour faster than the walker? So we have, this is the tortoise and the hare without the nap. So the jogger finishes first, and the jogger takes 40 minutes, which in hours would be 2/3 of an hour. I said 2, and I wrote 3. So 2/3 of an hour. And the walker finishes that same thing in 1 hour. How fast is each moving if the jogger runs 2 miles per hour faster than the walker? So what would we pick as our variable? Speak into the mic. Well, we're looking for speeds. So which speed, it doesn't matter which one we pick for our variable, the other one is going to compare to it. The trouble with story problems is often you introduce too many variables. We have a W variable and we have a J variable. And we pick either W or J, it doesn't matter which one we pick, and then the other one has to be in reference to the original. So do you want to pick your variable to be W or do you want it to be J? W. Why W? Okay, and it really doesn't matter. So the speed of the walker is W. What's the speed of the jogger? So J is W plus 2. And now we've eliminated the J variable and we have nothing but W's. So W, and again our formula is rate times time equals distance. W travels for 1 hour to cover the distance. But the jogger covers that same distance going how fast? W plus 2 times 2/3 equals distance, and we still have too many variables. But the D is the same. They covered the same distance, and we don't even know what that distance is, but we can set them equal to each other. So W times 1 is equal to W plus 2 times 2/3. Now, when I get W, that's not my answer. There are two speeds we need to figure it out. So if W is 3 miles an hour, then J would be W plus 2, which would be 5 miles an hour. Okay, we getting the hang of this? 63. College roommates leave for their first class in the same building. One walks at 2 miles per hour. The other rides his bike at a slow 6 mile per hour pace. How long will it take each to get to class if the walker takes 12 minutes longer to get to class and they travel on the same path? So we have common distance. One person is going, so the walker is going at 2 miles per hour and the biker is going at 6 miles per hour, and they travel the same path and get to the same place, but we know that the walker gets finished 12 minutes after the biker gets finished to cover that same distance? How would you set that up? Just what do we know about that formula and the walker? The rate is 2, so 2 miles per hour times the time would be the biker's time plus 12 minutes. Whatever the biker finished in, then the walker took 12 minutes longer. And that equation will give us the total distance, which we don't know, but that total distance is also equal to 6 miles an hour times whatever the biker took in minutes. So we don't, once again, we don't need this D. We solve that for B, and that will tell us, so that's going to tell us how long the biker took. What does the question ask? How long will it take for each? So whatever the biker is, you're going to add 12 to it. Can we use that number to figure out how far they traveled? You could. That's not part of the question. But once you know 2 parts of that equation, you can find the third. Okay? Turn the page. At the end of every section, you have these questions, and a lot of times we'll be working on them. You have the catch the mistake problems. So in the catch the mistake problems, it will give you the question, and it will give you a solution method, and it's always wrong. Somewhere along the way, they made a mistake. All you have to do is identify where the mistake is. Where did they go wrong? So, for instance, 75, 4x plus 3 equals 6x minus 7. We're going to subtract 4x and add 7 to the equation, which gives us 3 equals 6x. Divide by 3, and we end up with x equals 2, but that's not correct. Where did they make a mistake? Right. So we subtracted, if you subtract 4x, then you end up with 2x. So there's a mistake there. And once you get here, you should divide by 6, not 3. Oh, there are lots of mistakes. Okay, any one of the mistakes works. So if you find the mistake, that's great. Yeah, usually they only have one. It's odd for that one to be so off. But that one was terribly wrong. So, that's 75 and 76. The next two are sort of abstract problems. Solve for x given that a, b, and c are real numbers and a is not equal to 0. So how would you solve 77 without any numbers? Subtract b, so you end up with c minus b, and then divide by a. Why did they put that stipulation that a is not equal to 0? If a is 0, then you divide by 0 and you get infinity. Anything divided by 0 is infinity. So that's a problem. And 78, same thing. You have a more abstract concept. Figure out what that solution is. All right. Good luck.